On this episode of Database School, I talk with Jordan Tigani, who is the co-founder and CEO of MotherDuck. MotherDuck is a DuckDB hosting company, and they're doing a lot of very interesting things. And if you haven't heard of DuckDB, we do cover what exactly DuckDB is. It's like SQLite, but for analytical databases. So very interesting embedded database. We get into the difference between analytics and warehousing and lake housing, data laking. We talk about Duck Lake. We talk about all the Ducklings, kind of MotherDuck's business model, when you might use DuckDB, all sorts of good stuff. DuckDB is something that I see online all the time, and everyone seems to love it, and so this one was a lot of fun for me. I hope that you enjoy it enough for me. Let's get to the show. I am here today with Jordan Tigani, the co-founder and CEO of MotherDuck. Jordan, welcome to the show. And do you want to introduce yourself a little bit further?
Yeah, sure. Thanks so much, Aaron. Great to be here. Great to get a chance to chat. Hopefully, nerd out a little bit about databases and starting companies and et cetera. But yeah, I'm Jordan, co-founder, CEO of MotherDuck. We've been building this for a little over 3.5 years now, and it changes all the time, but it's still we're still having a lot of fun.
Well, that's what matters. So tell the people, we'll dive into some of your backstory, and I think there's some interesting founding stories here. But give us just like the high level overview of what DuckDB is and how it relates to MotherDuck, and then we'll dive into some of the details.
So, DuckDB is an analytical database. It's an embedded database. So analytical meaning kind of it's good at doing aggregations, computations, finding data versus like an OLTP database, which is sort of point lookups, point updates, etc. Sort of think Snowflake versus Postgres. It's also embedded, which is particularly interesting, which is that means that it runs in process. So it's just a library. You link it in. It lets it do some kind of cool things because it's embedded. Like if you're writing in Python, it can read and write directly from your pandas data frames. It can be super fast because no data has to be actually transferred to some other service. It's just a single binary installation, so it's much easier to actually install and get started and start playing with it. And so, kind of people use DuckDB for a lot of different kinds of projects. It's a great database. I didn't build the database, so I can say that it's awesome, and people tend to really enjoy it. It's got a great sort of like they've added some SQL syntax things that make it easier to actually write queries and write correct queries, and it keeps getting better all the time.
And then, so I'm hearing a couple of things that are analogous. So I'm hearing mostly it's analogous to SQLite in its embedded nature, and then something like a ClickHouse or a SingleStore, which you have history with, or something like that. More, I guess SingleStore is HTAP, but something like that as it relates to the analytical nature. So I'm kind of starting to get a sense of it's like SQLite, ClickHouse, Postgres, SQLite, like all those things kind of relate to each other. And then where does MotherDuck come in? Because you're like you said, you didn't create the database, but you're the founder of MotherDuck. And so tell us how that fits into this story.
Yeah, so at MotherDuck, we're taking DuckDB and we're hosting it in the cloud as a cloud data warehouse, or as a SaaS analytical database. So you don't have to know what DuckDB is to be able to use MotherDuck. But also, if you're using DuckDB, we make it very easy to switch to using MotherDuck just by actually changing your database name. So if you're using DuckDB locally, you're running it against a local database file, like call it foo.db. If you actually just change that database name to start with MD colon, instead of running it a local file, that'll run against MotherDuck running in the cloud. So it's super easy. You don't have to install anything different. It's not a different client. It just works.
Oh, that is interesting. We're going to have to come back to that because I think we need to lay some groundwork on the relationship between MotherDuck and Duck Labs because it sounds like it's pretty tight because that is very, very cool. So to extend our comparisons, Turso is a company that hosts SQLite, and so is it fair to say that MotherDuck is a company that hosts DuckDB, and it's basically the same kind of setup there? Is that about right?
Yeah, we even borrowed one of their descriptions of their tenancy model. I think Glauber from Turso called it hyper tenancy is how and with Turso you can have each one of your end users gets a separate SQLite database. In MotherDuck, you can have each one of your end users gets a separate DuckDB instance in the cloud, which is one of the things that lets us scale well because you might have um, thousands of users, tens of thousands of concurrent users. And if you're using MotherDuck, each one of those users can get a separate DuckDB instance, which can be tiny. It can be DuckDB scales down to super tiny, but it can also be giant. It can be like the size of the largest EC2 machine, which is terabytes of RAM, hundreds of cores, or anywhere in between. And so that tendency model means that you don't necessarily have to worry quite as much about people stepping on each other. Like some user is running really heavy queries, another user gets starved, and then we also can be really aggressive at shutting things down when they're not being used.
Yeah, this is really interesting because I'm in my head, the example that I'm thinking of is they don't, to my knowledge, use DuckDB, but a company called Fathom Analytics, where they are basically Google Analytics, but they don't suck, right? I like Fathom. I have no relationship with them, but I super like them. And what I'm hearing you say is in this scenario where they're taking website analytics, and I could have, as Aaron Francis, I could have my own behind the scenes MotherDuck instance, and then I think they actually host like, I don't know if it's CNN or Der Spiegel or something. They could have their own infrastructure back there that's much, much larger than mine. But everybody gets their own MotherDuck database, and it kind of keeps that noisy neighbor problem separate and, that data isolation. So it might make it easy for the application developers as well. Is that like a fair point there?
Yeah, absolutely. Yeah, if you're an application developer, you're building a SaaS app, you want to show analytics to your end users. It's just really nice because then each one of your end users gets their own isolated instance, and you don't have and from a cost perspective, like you're only actually paying when that user is actually querying, and then we shut things down pretty aggressively. So if you get a spike and you get 100 most of your users show up at the same time, it just works. And then they go away, and then it scales back down to zero.
Okay, cool. So we'll get back to this in a second. I want to back up because I want to hear. I think DuckDB is, in the database land relatively new. I think we're talking like 7, 8, 9 years old. And then you said you've been building this, which refers to MotherDuck, for I think you said 3 years. And so let's back up just a little bit. I know that part of your history includes SingleStore, and I don't know what's in the water over there, but it seems like a lot of smart people come out of SingleStore. So back up a little bit and tell me, how did we get to MotherDuck? And while you're doing that, why don't you describe Duck Labs and how that came to be a relationship as well?
Sure. Well, so DuckDB started. I think it's only been about 5 6 years now. And it was a couple of academics. So Hannes Mulhuysen he was at CWI, a research institution in Amsterdam, and had just gotten tenure. And then Mark Rosveld was one of his PhD students, had just finished his all of his papers for his PhD ahead of time. So they both had this 18 months to kill where nobody could tell them what to do. I mean, Hannes because he had tenure and Mark because he'd finished his PhD work. And they'd been using MonadDB for a lot of the academic stuff, and they're like, this is a pain in the ass, and I bet we could do it better. And so they started building a database, and they named it after Hannes's pet duck Wilbur. Um, that's how we got DuckDB, and they turned out to be amazing coders, amazing database developers. They built something pretty amazing, and And I started seeing it coming up, people talking about some comparative benchmarks when I was at SingleStore. So SingleStore, one of the things we really prided ourselves on was performance. And, like, it's like, hey, the reason that you use SingleStore, even though like it's not the database you may have heard of, is because it's like super fast. And DuckDB was giving us a run for the money in some of these benchmarks. It was like, wait, this is like a brand new database coming out of nowhere. Like, how is this happening? And so I started poking at it, and it turned out that like some of the stuff that people were asking us to do in SingleStore, like, and we couldn't do, DuckDB could do. For example, like we were like, it would be great to be serverless so that we could scale down. To do that, you need to be able to scale down to zero. And people like wanted to run us in like embedded situations, and like, yeah, that's really hard. But DuckDB was kind of really well designed for that. The other thing is we were spending all of our time, a lot of our time, building this complicated distributed system machinery, distributed transactions, distributed replication. Um, and one of the things I also noticed was one of our big enterprise customers was Sony. Sony is a big, real legit company. And instead of running in distributed mode, they were just running in these giant machines, like the huge machines, and and it was just working for them. Like they were happy. We never heard from them because like they didn't need support. It just worked. And I'm like, hey, there's something interesting here where basically instead, like, now that machines are so huge and really fast local disks and better faster network, like we can scale things up instead of like building complex distributed systems machinery, which A, make it hard to scale down. B, they slow you down a lot when you're trying to in terms of just the velocity of making improvements. And then C, they're expensive, expensive to maintain, expensive to that you have to pass on to customers. And D, they had a bunch of latency overhead. Um, so kind of put those together as like, hey, there's something in this DuckDB thing, and I was like, somebody should take DuckDB and host it in the cloud and build a SaaS service out of it. Like that seems like a really cool idea. And I got fired from SingleStore.
Oh, I
And
didn't know that.
yeah, yeah. I mean, it wasn't my favorite moment, but it was also like I'm quite grateful that that happened because like kind of the best thing. It was probably the best thing that ever happened to me in my career. Um, because then I was thinking, well, what do I want to do? And I was thinking back to this sort of DuckDB thing, and it's like how like, hey, maybe I'll just hack on this for a while and start building. Uh, and so I got about 2 days into it, and then I got an intro to Hannes and Mark because I wanted to see, hey, are they building something similar? I didn't want to like step on their toes. If they were, maybe they would hire me to work on it. So I got an intro to them, and I asked them, hey, are you guys building something like this? And they said, we really just want to focus on building a great database. We don't want to build a cloud service, and we don't want to like go through all the VC process and like, um, but we'd be willing to partner with you, like, because they knew of me actually from my BigQuery days, and they're like, hey, we think you could pull it off. I'm like, and that same afternoon, I got an intro the same person introduced me to Hannes and Mark introduced me to a VC, and the VC, I get about 15 minutes in, he's like, yeah, it's a cool idea. I want to fund it. Come to my partner meeting next week, and I'm like, okay. So it just, and then a bunch of people came out of the woodwork to like, who were also interested in working on it. Some people that I had worked with before, some people who'd been customers before, some people who kind of were just excited about DuckDB, and yeah, we kind of were off and running, uh, and haven't looked back since then.
This sounds incredibly fast and painless. I don't know if it was. I'm sure getting fired was painful, but you said you spent 2 days hacking on it and you're like, yeah, this is going to work. Let me go meet the guys. And you went and met the guys, and the guys were like, yeah, we just kind of don't want to do that. We just want to, be academics and build cool stuff. And then you met an investor, and 15 minutes later, he's like, yeah, sounds good, man. Was it really like that painless?
Um, 12 days from when I got fired, I had 5 term sheets.
What?
Yeah, it was a little bit silly. So it was, it was the heady days of 2022, um, it was, and it was, but there's a lot of tailwind. DuckDB was growing fast, and a lot of people had seen that Snowflake was doing so well, and like people were like, oh, what's the next data next big data company, and so yeah, that just made it quite easy. And I realized that not everybody's journey is like that, and I realized how fortunate that I was that it was that way. And but it was also kind of this was a great opportunity. I kept waiting for the other shoe to drop to be like, oh, it would be a good idea, but there's this thing that makes it not going to work. And like it kept being like, oh no, but actually it's going to be even better than I thought it was going to be, and like even better than that just sort of kept happening. And so yes, it was a very fortunate and auspicious start to the project.
Wow. Well, congratulations. And I imagine that makes the whole getting fired thing not quite as painful when 12 days later you have term sheets. So, what was your what's your background and role? You said BigQuery, you said SingleStore. So, were you building databases historically, or were you in some other role, or what's kind of your technical background?
I was an operating systems guy. I was like in, working on the Microsoft, the Windows kernel, and I worked in research for a little bit. I thought I was a compiler person, and then I got into big data. So, and then I went to Google because they were the ones who had figured big data out, like kind of way ahead of everybody else. And I get there, and was on a team that was tasked with building a data marketplace, and then we decided not to build a data marketplace. This was the Google of like 2009, where your manager tells you to go build something and you can say, no, I'm going to build this other thing instead. And the thing that we built instead was BigQuery. Uh, and so, and there was an internal database or internal engine called Dremel, but we sort of took Dremel and built a SaaS service out of it, and helped scale that into the cloud. And so I was an engineer, but I was the tech lead for BigQuery storage, and I ended up leading BigQuery engineering for a while. And then I led product. I switched over to product and led product. Got us to about 1 billion in ARR before going to SingleStore as the chief product officer.
Okay, there you go. So you've got both. You've got engineering, you've got product. So that makes sense. How you were able to hack together a demo or a proof of concept, and then how you're also able to be, the CEO of a product company. And so you get these term sheets, 12 days after getting fired. I hope you at least had, a few days off there as well. And then you start putting together the actual MotherDuck service. So talk to us, how long did that take? And then who or what type of customer was first?
Yeah, so I guess one of the other key things we did was that we forged a partnership with DuckDB Labs. So DuckDB Labs is a company created by the DuckDB founders that to work on the core DuckDB, but they have their business model is support. So you can basically pay them to add features, and you can pay them for DuckDB support. We gave them a co-founder share of the company because we wanted to deeply tie ourselves to them. In exchange, they gave us like an exclusive, so they won't work with anybody who's doing something competitive to us. And they also gave us sort of like this thing I mentioned, which was like, deep integration into DuckDB and distribution with DuckDB. So it's been an awesome partnership, and it's been one of the kind of key parts of the company is just sort of staying close to the DuckDB team, because we wanted to make sure that we didn't have to fork DuckDB. So we run stock DuckDB. We'll get some fixes and features for DuckDB, and we'll run those on our server, ahead of releases, but it's there's not like the MotherDuck version and the DuckDB version. Is everything that we do is sort of built as a DuckDB extension. So it took us kind of I guess we had various stages of prototypes. It took us like a few months to get to sort of a very early alpha that just showed something working. Beta was a few months later. Actually, beta was, I guess, almost a year from when we started. But that was like when we thought we had something that like this is actually useful. It was another year of beta and refinement to get to general availability and something that we actually thought that something that people would want to pay for. And then it took about 6 months of like figuring out how to get the pricing and packaging right, and actually selling it, and kind of starting early this year. We kind of think we had the go-to-market side actually working, and since then like sales have been very, very pleasantly up and to the right. And so who are our the key customers, like one of the lessons I learned actually from BigQuery was there's a lot of money in the long tail. There's a lot of customers in the long tail, but all of the energy is being focused on enterprise. So everybody is like, it's like chasing after these same Fortune 100 companies, and taking the CDO out to a steak dinner and like saying, "Can you run these long POCs?" And the long tail, was just there's lots of smaller companies. They do a lot of really interesting things, and so we decided to focus on the long tail, the startups, the SMB, the mid-market companies. Because they're the enterprise seemed oversaturated, and B, nobody was really selling to these people. I mean, yes, there's a snowflake salesperson that will like very aggressively chase down these people, but like if they want support, if they want kind of if they're not getting exactly what they need, they want somebody to help them like get things integrated, etc. Like they're kind of on their own. And so there seemed to be a big opportunity there. And also the ability to just build something that like if you can really win over the hearts and minds of those companies, like it forces you to build something really amazing. Like it's like you get fit rather than like you sell a couple of big deals to these big enterprise companies, and you think you're doing great, but like it turns out nobody really cares, and so I think the other thing is you really get to focus on like you have an engineering team and a product team, and it's like you have to decide what is each person going to work on, what are we going to build, every feature you're going to build. Like, do you want to put those people on making the product amazing, or do you want to put them on these enterprise checkbox features that that Walmart is going to make you build? And yeah, we'll 100% get to that. Those things are important, but we wanted to focus on like how do we build an awesome product as soon as possible.
Yeah, I unfortunately spend a lot of time on Twitter, which is not great, but I have seen MotherDuck and your team talking about DuckDB a lot, and it seems like it has won the hearts of the Twitter people. It just seems like everybody loves DuckDB, and by extension, everybody loves MotherDuck because y'all are putting out all these great resources around DuckDB and all these interesting blog posts. I'm curious, you mentioned a second ago you had to figure out the pricing strategy, and then you went into you're able to attack the long tail. So is there some connection there that between pricing strategy, cost profile because of the way it is an embedded database, and the ability to attack this long tail of people that either other companies aren't going for or can't go for? Is there any sort of overlap that makes all of that work?
So I think one of the things that we had thought from the early days was, it's like, hey, we're gonna have lots and lots of super high volume, super low cost. And so we're thinking, hey, we want to make us thinking of a $25 a month data warehouse. And so that's what we sort of originally priced it at. And we noticed two things. One is people thought it was a toy. They're like, oh, a $25 data warehouse is, that's, not for any real workloads. Like they didn't trust it. And then second of all, the people that were using it, um, we realized we were just leaving a ton of money on the table. Like we would talk to a customer, and the customer would be spending $30,000 a year on their BI tool, and then they would be spending $600 a year on MotherDuck. And it's like, wait, there's clearly a willingness and ability to pay if they're spending 30K on a BI tool, and they're using us as their main data warehouse. So we kind of realized that we had a lot of opportunity to increase prices. So we increased prices, and um, and demand actually shot through the roof. You kind of expected it would be the opposite, but as I think people just felt like, okay, this is real. We started. I mean, since then we also started doing actual sales, and I think there's a tendency for technical founders, myself included, to be like, we're going to be PLG because PLG means people, if they find the product, they start using the product, they love the product, and then more people start using the product, and um, that is hard. That's a hard path to go. It sounds easy because like I don't have to talk to anybody. As an
That's
engineer,
the dream.
as an introvert, like it's nice when it's like I don't have to do sales. I don't have to like, pitch people and
Yeah.
try to convince them and deal
And
with.
it appeals to this platonic ideal of like, if it's good enough, people will understand it. And it's like, we all want to believe that, you know?
But one of the problems with that is like you get very little feedback when it's not working because like, somebody tries it, they go away. All you have is the path that they went through, and like you can instrument that and you can look at it and like, oh, well, what happened? And like, but you don't actually know. You didn't hear from that person. You can send them a survey, you can ask to talk to them, but they've already decided, they've already moved on to something else. Um, and I think that's where like, a more traditional sales model is super helpful because a more traditional sales model, you actually have a person, you have a relationship. And if you're not delivering what they need or you don't have what they need, they tell you. And they'd be like, we really need, different instance sizes. We need SSO. We need, this thing. And you're like, okay, well, I can go deliver that. And that ends up being much faster and better, um, uh, better feedback loops to hear what people actually want and then go and deliver. You just have to make sure that the people that you listen to are the ones that are the customers that you want. Because like otherwise it sounds bad to say like customer tells you something and you don't do it, but of course like you hear lots of things from lots of different customers and you can't do all of them. And so I think the art of product is sort of take all those requests and A, prioritize them, but also B, recognize that when like this customer asks for like this one thing and this customer asks for something slightly different, that you can deliver a third thing that they never thought of that like actually solves all of those problems at once.
You mentioned instance sizes there, and earlier you mentioned serverless and scale to zero. So tell us what is the pricing model and what is the, I guess, the cost structure on your side? Because if you're going to scale to zero, you got to be able to scale back up pretty quick when people start doing requests. But you're also talking about setting instance sizes. So talk to us a little bit about resources and how the end user or the business pays for these things.
Yeah, so originally we said we're going to do pure auto scale, serverless, etc. Um, and I think that's not actually what people wanted because if it completely auto scales, like you don't exactly know what you're gonna pay for, and the needs in analytics, they can go from zero to very high in a very short amount of time, and then back down to zero. And so you're always going to be sort of like chasing the scale. And also like, often if you throw more hardware at a problem, it'll run faster. And so the the ideal amount of hardware to throw at a problem is not design. It's actually based on the impatience that the user has versus the data involved. Because you could use half the hardware and it would take twice the amount of time. Does the user want to, does the user want to write now, or are they will like so? Um, and so what we did is we have a kind of a Pulse instance, which actually we charge by the second, and it's for smaller workloads, but we can run lots and lots and lots of these, and uh, we charge them by the second. We also call them the sort of the minimum viable duckling. Duckling is what we call instances, um, and
Ridiculous, and I love it. That's perfect.
it's got some bursting capabilities, and so. But in general, any problem that you have, you should be able to use the Pulse duckling. Um, but then we also have like other instance sizes for when you say, hey, I want to, I'm willing to pay this much, and they are sort of fixed sizes. They're sort of somewhat anchored at targeting sort of the snowflake instance sizes. So our like standard instance size is roughly equivalent to a Snowflake small. It's about half the price of a Snowflake small, and I think in general we can get significantly lower latency than a Snowflake small, so it can be a quarter of the price or a tenth of the price of Snowflake. And then we have a couple larger instances. Our largest instance is 192 cores and a terabyte and a half of RAM. And that's actually roughly the amount of hardware in a Snowflake 3XL, which is $1 million a year. And so um, so people are like, oh, DuckDB, it doesn't scale or whatever. It's like, well, actually, if you can use less than a Snowflake 3XL, um, chances are, this is gonna work for you. And we also run a separate instance per end user. So if you have like one of the reasons you might need a giant Snowflake instance is because you have lots of users running concurrently. But now we can give each one of those the equivalent of a Snowflake 3XL. Most people don't choose to do that because uh, uh, that's a lot of hardware to throw at something. But maybe one day.
Yeah, that's cool. Okay, so am I hearing correctly that you've got these configurable always on instances, but you also have you said I think you said spiky. Is this like Lambda where you can say, "Hey, I've got my configurable always on instance and then I want to be able to burst up using this fluid compute, so like Cloudflare Workers, Lambda, something where you can pay by the second?" Or is it you pick per project and you say this project is like it's kind of like seasonal or like doesn't really matter, so let's use the spiky version, and this one is always on, so let's use the instance version?
Actually, they're not always on. Even the other instances, they shut down. We pretty aggressively shut them down. We shut them down after 60 seconds. And so the other, I mean, we have slightly more expensive storage, and the reason we have slightly more expensive storage is because we keep it reasonably hot. So we use a bunch of sort of local cache, memory cache, flash SSD cache, and so we can start these instances within 100 milliseconds, and so we can shut things down aggressively, and then you run another query, and then it's kind of your data is instantly available, and so that kind of helps with that also is one of the things that helps with costs considerably. The other thing we can do is we call it read scaling. Is we can, if you do run a bunch of queries, um, they we actually will kind of fan those out to multiple, dynamically scale that out to multiple ducklings, and those can be actually smaller. So you might have, very often what we have is we have like people do like big transformations in their kind of their main instance. They need kind of a relatively hefty instance for that, and then they run their BI queries, and their BI queries actually are relatively small, and so they'll have like 16 of these like read scaling ducklings, and one like jumbo duckling that they do the transformation in, and we can sort of like dynamically manage those all behind the scenes.
First of all, hard to have a serious conversation when we keep talking about ducklings, but it's great. I love it. Secondly, forgive my ignorance here. How are you scaling out? Is everybody talking to the same drive? Because how are you doing that if it's like an embedded database? That may be a silly question, but it's on my mind.
No, that's a great question. Uh, and that's sort of one of the special things that we can do in MotherDuck. So in DuckDB, when you open a database, uh, it takes an exclusive lock on the database file if you open it for write, and that means you can't even open it for read at the same time. And so what we do is we have one Duckling that owns that database, and then we flush data out to, we have this sort of append-only file system, and then we kind of, via that, we actually build a separation of storage and compute and let readers actually read from that same from that same data without having to sort of violate the DuckDB file semantics. So there's only one user can be writing to a database at once, but we can have lots of read users. And to an external user, it actually looks like the same database. We have a single endpoint for everything in MotherDuck, so you don't have to have okay, this is the URL for this database or whatever. It's just one URL to MotherDuck, and we reroute you to the right backend. But then we can actually fan out the reads to these other Duckling instances that can read to the underlying storage that has the sort of the read snapshots of the data.
So you've got the big dog, you've got the let's say giant compute instance, and that's probably the one that's in charge. And then you spin up these read replicas, and the big guy is still the only one that's going to acquire that write lock because it's presumably got the most power and it's in charge. And then the read ones can kind of come in underneath and read what that main one is doing. Is that close enough?
Yeah, no, that's exactly right.
Okay. And to the extent that it's not secret sauce, can you tell me how this is set up? First of all, is it AWS? Is it cloud agnostic? And then what machines and what volumes and what's some of the stuff underneath to map on these theoretical concepts down to the machines?
Yeah, so the bottom of the storage stack is just S3. So we do cold data stored on S3. We kind of built a tiered storage system. The higher storage tiers are our memory, memcache that we also store on local flash, on local SSDs. That's also distributed. And we built this differential storage system, which essentially, because if you're storing data on S3 is immutable. It's once you've written a file, you can't go in and change something in the middle. You can overwrite the whole file. So what we do is we sort of make it look like you can do read write, which is sort of what DuckDB tries to do to its own data. But every time there's a write, every time the page needs to get flushed, we'll basically take that whole new page, append it to the end, and then we have a mapping that basically says, okay, this is now the new page to use. And the nice thing about that is then it lets other readers access the older versions of it, and have essentially snapshot isolation, because they have a stable version that they can look at. They don't have to synchronize with the other instances that are running. And so we are running AWS. It's not, we're not really using anything that's AWS specific. We will likely, be multi-cloud at some point. We have a very thin routing layer, which is Cockroach, but then locally per region we have an RDS instance. We have a storage RDS instance that sort of manages the mappings to this for differential storage, and then we use Kubernetes to sort of manage the instances. But we also do a lot of kind of custom stuff on top of the Kubernetes to sort of provision and route and route you to an instance within 100 milliseconds.
Okay, this is super helpful. So this is starting to make sense to me. The thing you said earlier about the read or the replica scaling, because the main duckling, I want to call it the mother duck, but that's the name of your business. The main duckling is in charge of this, like, flushing the pages to S3 and updating the pointers to the most current version of, the pages. And so that's what the main duckling is doing. But while it's doing that, these other replicas can be, of course, reading from S3. Anyone can read from S3 at any point in time, as long as they know that they're reading the right thing. And so presumably when they start reading, they get some local copy of the page map that says, like, here are all the pages and their current versions. Just read those. And when the big dog doesn't delete the old pages, that means the replica can keep on processing its potentially long running queries while it's updating the new stuff. And then when the replica starts again, it probably gets a new version of that page cache, and then it starts reading updated data. Is that all close?
Yeah, exactly. The only slight difference is that we don't have to wait till things restart. We can kind of proactively provide the updated data, and the changes kind of as you know as those changes are committed.
Cool. Where and how is this integrated into DuckDB? Is it because you said earlier you don't run a separate version, which is gotta be one of the best competitive advantages that you have, is that you can do MD colon and it opens up on MotherDuck. That's what Turso's been fighting against from the beginning, is they don't have control over SQLite. And so this sounds amazing for y'all. So but you said it's the same and everything's implemented via extension. So talk to me about, I know in SQLite there are extensions, there are also storage backends. There's a lot of weird stuff in SQLite because it's 1,000 years old. So how are we implementing at MotherDuck? How are we implementing this differential storage engine such that DuckDB just like slots it in and you're good to go?
So yeah, a couple of things. One is we implemented the differential storage actually as a storage driver, a file system, using Fuse, versus inside DuckDB. Partly because when we started, DuckDB was changing very fast, and we wanted to make sure that it wasn't a lot of work to try to synchronize those changes with complete storage. Also, we wanted to be able to sort of build to sort of a fixed, well-known interface, so that, like, as things change, we can evolve those separately from DuckDB. But
So
we
in your implementation, DuckDB knows nothing about this underlying thing. It just looks like a storage layer to it.
Yes, I mean, we do have
Cool.
some hacks, some like things that
Sure.
we poke through the abstraction boundary, to make it work well. But we also have we have a server side and a client side DuckDB extension. So one of the kind of the more unique things about how MotherDuck works is DuckDB is our client, and that's how this sort of MD colon thing works. Is like, so you're running on your laptop, you have DuckDB running on your laptop, and you connect to, in Python you do connect, instead of foo.db is connect MD colon foo. And that loads our extension, and then when you start running queries, there's a local copy of DuckDB, and if the query that you're writing runs against local DuckDB data, then everything runs locally, nothing touches the cloud. But if you run against cloud data, then it runs in the cloud. Now, if you join your local data against your cloud data, we use the DuckDB cost-based optimizer, and we actually figure out, like, how to move the minimal amount of data, so, like, chances are it's a small local data, local table, and a big cloud table. So we'll push just the pieces that we need into the cloud in order to execute it on the cloud. We call this our dual execution or hybrid execution, and And so we have a very elaborate, local DuckDB extension, which can sort of pull the query plan apart, and like it does the binding, locally, and synchronizes the catalog. Um, and then we have a server-side extension as well that sort of handles all the stuff that we need, the observability hooks and stuff that we run on the server side.
Wow. Cool. So cool. Absolutely incredible. I love that. The idea of like breaking a query apart from local machine to cloud and doing joins across both, that is some mad scientist stuff. You've mentioned two words a bunch of times. One is analytics and one is warehouse. Talk to us about the difference, just for the dear listener, the difference between analytics and warehouse, and perhaps the similarities, and then where DuckDB and MotherDuck serve one, the other, or both.
So I think analytics is just, to me, is the type of questions that you want to ask of your data, is um, aggregations and computations over, you know that require kind of looking at larger swaths of data. Who are my top salespeople? What is the fastest growing region? Which marketing campaigns are working well? That involves like comparison of data versus like um, you know uh, you know what is this username, or what is the user's you know the user object, so that like, instead of like, which is sort of an OLTP kind of lookup that you can do almost like as a key value store kind of thing. um, so I think analytics is, yeah, the ability to run queries over, ask questions over across data. um, then warehouse is sort of a type of, it's machinery that um, lets you combine your data in a single place, provide like data governance and security, and a bunch of sort of mechanisms around the data that allow you to operate over it, in a group situation. So you may have like data people, you may have BI tools, you have ingestion tools. You want to manage security. You want these people to see this part of the data, but not that part of the data. Um, and it involves a lot more than just like being able to ask questions of the data. Like that's sort of the way I like to think about it, is like sort of the analytics engine is like the engine of a car, versus a warehouse. You sort of have to build the whole car.
And then with that foundation laid, what is a lake and what is Duck Lake? So what do we say? I mean, I love that it's Duck Lake, but what is that, as compared to, let's say, the warehouse?
So I think the lake really grew out of the sort of the Hadoop era, where people are saying, "Hey, I'm just going to write a bunch of data out, and I'll figure it out later." And then you have a query engine, comes on top, and it's starts to sort of pull pieces out, of the data that just sort of gets dumped into a single location. Like typically that's S3 these days. Um, and then one of the problems about that is, like, say you're writing, say you write a new Parquet file every hour um, to an S3 bucket. Uh, Now, if I run a query, um, then I may or may not see the new file. Like there's no sort of like transactionality. Let's say you write something out, you write out a file, and you realize like you screwed something up, and you want to go and delete something. If somebody's running queries over that, and like files, a new file shows up, the file was deleted. There's sort of no ability to really understand, in a clean way what data is there. Also, if you're adding files every hour, over time that's going to be a ton of files. So you're going to want to like compact those files, small files, into larger files. You can't really do that transactionally, so you have to make sure you're not reading while you're doing that. Um, and so people have been building sort of these lake house technologies, which are sort of like, they basically say, no, 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 don't just list the bucket. we're going to have a manifest file. The manifest file tells you which Parquet files to read. And the nice thing about that is then if we change a bunch of these things transactionally, or we add some more, we can then just change this manifest file to tell you to read different Parquet files, which is nice because then it lets you kind of add transactions to your data lake. But on the other hand, like you end up with a lot of manifest files. And so this is, Iceberg and Delta are, these sort of lakehouse technologies. And, you have the same sorts of problems where you can have lots of these manifest files. You can't really do multi-table transactions. If you're writing data out very quickly, instead of every hour, you're writing every minute or every 30 seconds or every second or 10 times a second, then you end up with this sort of this mess. So Duck Lake is a mechanism that sort of recognizes hey, there's a need for having these kind of open. The nice thing about these formats, Iceberg and Delta and Hootie, is that anybody can, once you've written data out in this format, any tool can have the same access to the tool. So it's like if your data is in Snowflake, it's locked up. Nobody else can access it. If your data is in BigQuery, nobody else can access it. If you're using Iceberg, you can read from it. You can read from it from Snowflake. You can read from it from Databricks. You can read from it from DuckDB or Trino or any other tool that knows how to read Iceberg. But I think Iceberg is it's very difficult to manage, and also in order to sort of to have it just be okay, well, it's not just one table. I want to have a set of tables. People added catalogs, and so the catalogs that tell you which Iceberg metadata files that then tell you which Parquet files to read. And so you have a database, and you have a bunch of metadata files, and so the Duck Lake, kind of the key insight with Duck Lake was, okay, well, if you're going to have a catalog, which is a database, why don't you move all this work up into the database, and then you just have the database which tells you which files to use, and it's just a much cleaner abstraction. It's much easier to build a connector because you run a couple SQL queries, and the SQL queries tell you which files to read. It can even let you do things like partition elimination and help with filter pushdown, and you get statistics and statistic aggregations and all sorts of things that are hard. You can do those really easily in Duck Lake. So Duck Lake was first launched a couple months ago. I think it was in the spring as an alternative to Iceberg, and it's just you can get started in I don't know, 10 seconds, literally 10 seconds, install DuckDB, create Duck Lake, add files, you're basically three commands and you're done. And in MotherDuck, we have a hosted Duck Lake, and so that takes the catalog, also lets you run queries, but also if you want to run an external tool that also knows how to talk to Duck Lake, you can do that as well. You don't even have to use MotherDuck.
Can you tell me, and this is just my lack of experience, can you tell me what people are using Duck Lake for? What types of problems they're solving with it?
It's the same. I mean, it's the same thing they would be using a lake house or Iceberg. The typical thing, the typical reason I think that people use Iceberg is that they want to use more than one engine against the same data. I think it's quite common that somebody has Snowflake and Databricks and Spark. They're doing sort of machine learning stuff, and then they're also doing sort of data analytics. And the same, you can do the same sorts of things. I think one of the nice things about Duck Lake is that it lets DuckDB scale. It lets DuckDB scale on a data size. So if you have more than 10 terabytes or so in a single DuckDB database, it starts to kind of bogged down a little bit. There's a lot of like per segment metadata. There's a lot of it's just sort of not designed for that scale. Whereas in Duck Lake, you can have petabytes, and you can still run DuckDB over it and get very good performance because generally it's pretty rare that when somebody has a giant database that they actually have to scan all of that data. They have to read all that data. It's usually they do partition filters, they do other types of filters. They read data for a particular user, or a particular the most recent week or most recent day, um, and so you can have giant amounts of data, and then what you're looking at is actually a small slice of it, and then that works really nicely with DuckDB.
So it sounds like if I'm hitting some DuckDB limits, which I suspect a lot of people do, the majority probably don't. 10 terabytes is quite a bit. But if you do that, you can create a Duck Lake, and you can interact with it in the same way, but underneath a lot of different stuff is going on. But to you, the consumer, at least for this consumption point, it's as if it's a DuckDB database, but then other consumption engines, points, tools can all consume that as well. Is that right?
Yes, exactly.
Okay. Okay. All right. That one, lake houses, warehouses, that's a little outside my historical range of expertise. So I appreciate you walking me through all of that. One of the final questions I have goes back to talking about the long tail of people that you're seeing come to MotherDuck. When you see some of these more small medium businesses come to you, are they coming from another analytical solution, or are they coming to you from an OLTP that's breaking down? Because I guess my thought is this feels like a very nice and approachable on ramp into the analytical database world. And I would think you might be getting a lot of like, hey, we've been using Postgres, we've been using MySQL, we've been getting by, but boy, is it not great. What else is out there? So do you see one type of workload in that segment of the market, or is it just kind of all over the place?
So we see both. I mean, there is a handful of sort of the Postgres graduation users who kind of they bang their head against what they can do in their OLTP database, and OLTP databases just are not designed for answering these types of questions. Um, but we also do see a bunch of people who like are using Redshift, Snowflake, ClickHouse. I mean, Redshift and Snowflake, it tends to be they are they feel like it's overkill. They feel like, hey, this is kind of designed for a different um, architecture point than where my company is at, um, and we can be a lot less expensive, and so sometimes they see like their costs are escalating, and they want to get ahead of those, and so they switch to us. And we like to say, people come to us for the cost and they stay for the performance because we can also be a lot lower latency. Um, so yeah, I think we see a mix. I think one of the interesting things that we're also working on, that we have helped create is PG DuckDB, which is a Postgres DuckDB extension, and it lets you run DuckDB inside Postgres. I think one of the tricky things is that Postgres is used to sort of owning the machine. Kind of it has a notoriously quirky concurrency model where it has every connection is a fork and doesn't use threads, um, uh, and it doesn't always play well with like if you have an analytics engine that very very heavily uses threads, very aggressively consumes memory, is used to using all the CPU and memory on the box, and then you want to add concurrency, so you want to have lots of these things running. Um, kind of you get this sort of so it's nice for kind of some smaller workloads and some things where like okay, you have low concurrency. Um, uh, and so, but one of the interesting things about PG DuckDB, similar to what we mentioned, is with DuckDB is when DuckDB is the client for MotherDuck, we have this hybrid execution. You can do the same thing in PG DuckDB. So you can use PG DuckDB to then talk to MotherDuck. And so that will let you offload the analytical size of your queries. So you can run the OLTP queries locally on the Postgres, and then you run the OLAP queries in the cloud at MotherDuck. You can even join data between the two. And that lets you use the same sort of read scaling, and so you can have high concurrency. You can have you can scale it up, and scales back down to zero, and you don't have to run like a giant Snowflake or giant Postgres replica that does your analytics.
That is cool. So then is Postgres with PG DuckDB, that's kind of just like an interface through to MotherDuck, because all the compute, or most of the compute, is happening out on y'all's servers, right?
Yeah, for your analytics queries, but you can actually have that same Postgres be doing your OLTP workloads, and just natively, and then when you need to maybe access the OLTP or the OLAP, the analytical data set, or data, you can even join that against your most recent OLTP data. That all just works.
That's pretty cool. That's very clever. I can't imagine what happened, under the hood to make that possible, but it sounds like it's very clever. So as we're approaching the end here, why don't you give us the pitch for who should be using MotherDuck, when they should start thinking about either DuckDB or MotherDuck specifically, and then what, if anything, you would request from the listeners, whether that's job applications, open source, whatever. Like, just, you got a bunch of database people listening, so go ahead and talk to them.
Yeah, so if we think that we are a great analytics engine data warehouse for startups. We can give you a much higher touch, better experience than Snowflake ClickHouse. We are earlier in our journey than some of those companies are, but we're also moving super fast. DuckDB is improving at a very rapid rate. We had sort of expected. I mean, that was one of the things that I was most excited about DuckDB, was just how fast it was getting better, and expected that to slow down, and it didn't. Just the last a month ago, we updated to DuckDB 1.4, and it got 20% faster, which is for a quarterly release, is quite good. And a lot of the things that had been most slow got a lot faster. So it wasn't completely just faster across the board, but it's like the things that were painful now are a lot less painful. And so DuckDB is getting a lot better. We think we have a really good product, priced well. It's fun to use. We have sort of a good team, and so we'd love to hear from anybody who is looking for an analytics database. And regardless of whether you use MotherDuck, DuckDB is an extraordinary piece of software, extraordinary for like being able to ask questions of your data, whether it's on your laptop or creating a duck lake, querying over your Parquet files in your company's data lake. It's open source, and would encourage you to check that out and play with it. And it also has a great community extension program. So like DuckDB gives deep access to sort of database internals, and so you can add types, you can add indexes, you can add really interesting things to DuckDB via extensions. And so there's a lot of community extensions already, but if you kind of have an idea of something that might be interesting, like I encourage you to check that out. Write a DuckDB extension.
Wow, so cool. And is MotherDuck hiring? What types of people are you looking for, and how can they get in touch?
We're absolutely hiring. Engineers. Kind of from the front. We have front-end engineers, back-end engineers, database engineers. We're hiring, sales engineers, DevRel.
That's about everything.
Yeah. We're growing really fast, so we're hiring a lot of people. We've been kind of conservative on the hiring side up till now, until we kind of wanted to prove that we had something that was working, and now it seems to be working. And so now it's just about turning up the volume.
Amazing. Well, thank you so much for doing this and for explaining all of this to me and to everyone else. This has been an absolute delight. Tell the people where they can find and follow you online.
I'm on LinkedIn, Jordan Tigani, Blue Sky. I think it's Jordan Tigani with the vowels removed. Reach out. Happy to chat.
Awesome. Well, thank you for doing this. And to all of you listening, thank you so much for listening. Please make sure that you subscribe either on YouTube or in your pod catcher of choice. And do let me know who else you want to hear on the show. This is super fun for me. So cast the nets far and wide and find your most interesting database people and send them my way. Thank you again for listening. And Jordan, thank you again for coming on.
Thanks. This was fun.